All right, so we're now going to use all the information that we know about the different types of line equations, linear equations, to solve word problems. So I'm going to break it down into different word problems and the different forms of the equation. Ultimately, you're going to have to get to a point where you are given an equation, or given a word problem. You're going to have to figure out which form of the equation to use, but I have it broken down into the different types. So I'm going to do a couple from each section to kind of get you warmed up as to how to use it and when to use it and so on and so forth. All right, so slope-intercept form, we know we're looking for M, and we know we're looking for a starting point B. Okay, so the idea here is when we do this is a rate of change means some sort of rates going on, miles per hour, dollars per ticket, that kind of thing, cost per ride in this case. So some things are changing and some things are not. So usually in these types of problems, there's one rate that could change with every amount of tickets that you buy or amount of items you have, and one thing that is set, like a fixed cost. That is going to be the y-intercept part. Okay, so what we're going to do is we're going to hunt down two things. We're looking for some sort of rate, and we're looking for some sort of set amount. So this is a set amount here, usually. Or starting thing. So if you, for instance, had a plumber having to come over and fix your sink. Soon as that plumber walks into your house, you will have to pay him or her a certain amount just to walk in your door. So they may charge you a house call of $60. So if they show up and do absolutely nothing, they just do absolutely nothing, you're still going to have to pay them $60. Now, for each hour that they stay, they will charge a rate on top of that. So that's what I mean by set. That's an example of some of the set amounts. So that $60 would have been the set amount. And then his rate might be, or her rate might be $40 an hour. So you're paying an extra $40 per hour. So as time passes, that's changing. So that's why we're going to do that as your slope. All right, so you and your friends plan to attend a county fair this weekend. The admission to the fair is $5. All right, so there we go. So this admission of $5 is going to be your set amount, because even if you walk in there and you don't go on a single ride, it's still going to cost you $5 to get in. So the B on this is $5. Okay, that is a set amount. And it says the cost per ride. So the key is you look for words like per, miles per hour, something per minute, per. So PER. So look for those words like that. So this is our rate. So our cost is, looks like 50 cents a ride. So if your parents gave you $20, write an equation and then find out how many rides you can go on. All right, so your rate is going to be, your M is going to be that 50 cents. All right, I'm going to put it as 0.5. All right, so our equation is going to be y equals 0.50, that's the 50 cents, per ride, and we're going to use X for rides, okay, plus that $5 that you have to pay just to walk into the fair, okay? Now, they tell you if your parents gave you $20, how many rides can you go on? So remember, this is the number of rides. So in this case, we're solving for X. So that $20 belongs here with Y. So our equation is going to look like this. Okay? So that's the total amount. Remember, this whole formula is for cost. Okay? This is total cost of you going to this fair and going on rides. All right, so that's it right here, and they gave you $20. So how many rides can you go on? Well, remember, you have to take away the 5, which makes sense because you automatically have to pay $5 to walk in, right? So take that away, and that means you spent $15. You can spend up to $15 on a ride. So how many rides can you ride on? Well, divide by 0.5. X is going to give you 30 rides. So 30 rides is what you'll be able to go on. I feel like this is kind of the kind of thing that, you know, I guess it's a fair, so it's cheap, but when you go to an amusement park, it's not that cheap. Anyhow, 30 rides is the answer to that. I can show you on Desmos how you can solve some of these as well. If you get the equation correct, I can show you how to do it on Desmos to help you figure some of these out, but we'll just keep going for now. All right. So number 2, while your family is visiting Deep Creek Lake, you and your mother decide to go boating. The rangers charge $6.50 per hour. Okay, so that's M. All right, so this is M, because that's our rate. Okay, and in addition to a $25 deposit. So again, that's your set amount. So that's your B. All right, to rent a canoe. All right, because the idea is if you get in there, let's say you were to rent and go boating and you are going to get this canoe, you have to shell out $25 and then you have to turn around and pay $6.50 per hour. I'm not in love with this problem, only because a deposit usually is returnable. So, but it's not really a cost, but we'll just pretend that it is. But anyway, any set amounts are always your B. Anything that's a rate is always your M. So our equation is going to be, for renting the canoe, Y equals, all right, we're paying $6.50 per hour. In the case per hour, X is the hours. Okay, so just keep that in mind. X are the hours. Y is the cost. All right. Okay, $650 for X and plus the $25 for renting the canoe. You want to rent the canoe from 12:30 to 3:30. What's the cost? All right, from 12:30 to 3:30, this is 3 hours, right? 12:30 to 3:30 is 3 hours. So that means in this case, they want to know what's the cost. So we're going to put in the 3 where the X is. All right, so 3 times $6.50 is $19.50. It's $19.50 plus 25 is $44.50. So that's how much it's going to cost you to rent for you and your mother to rent this canoe for just 3 hours, $44.50. All right, next one. Your parents have decided to buy a new Toyota 4Runner. I can definitely tell that some of these problems are quite old, because there's Toyota 4Runners are probably about $50,000 now. But all right, so you're paying this. According to the dealer, the car will depreciate at a value of $3,000 per year. Write and solve an equation of how many years until the car is worth $3,135. All right, so we started off. So here's the starting cost, or starting amount. Okay, this is we'll just call it the amount, the value. Okay, I should say that. Let's change that to value. So that's the initial value. So in this case, we're going to write where Y is going to be the how much it's worth. Okay, so that's the worth of your car. So what we're going to do in this case is we're going to take away I'm going to write it MX plus B, but you have to understand that we're going to be taking away from the 25,635. So I'm going to write it that way, and then I'll rewrite it so it looks like MX plus B. So we're taking the $25,635, but we're taking away from it $3,000 per year. Okay, remember X is years. Just so we know. Again, when you're saying per year, now you know what X is. Per hour, you know what X is. X are hours. That's how you can do this. Per ride, we know that X is rides. All right, so that's the best way to remember it is after the per part, that's what X is. So this is 3,000 per X. I'm going to think it that way. All right, so it starts off at 25,635, and it's taking away 3,000 per year. So if I were to rewrite this just so it's in MX plus B, it would look like this. It's dropping 3,000 per year, and you started off at 25,635 because that's the start. Okay, so I just rewrote it. All right, so I have this, and they want to know when is the car, how long will it take before the car is worth $3,000? Now, where do I put this? Remember, X stands for years. That's not a year, that's a dollar amount. So that must mean it goes in for Y. Alright, I'm going to take a second and I'm going to show you how to do this with Desmos. So give me a second. Alright, so I've put a Desmos up side by side so we can do this with Desmos. So you can really, if you want to, solve these with Desmos. So all I want to do is find out what X is. So what I'm going to do is I'm just going to type in my last line I had here. Alright, so if you notice, I've typed this in, and once I do that, there's this line that appeared. Sometimes you can see it on the graph right away, sometimes you can't, but look, if it shows my red line, and if you hit this dot right here, it'll tell you. Look, it'll tell you that it's 7.5 years. So your answer is 7.5 years. So if you use this where you have an equation you don't need to get solved, you can just put it in Desmos, and anything where it hits the x-axis, because you're using x, anywhere you hit the x-axis is the solution. So, all right, so we'll do this next problem, but this time I will not solve it. I will just put it in Desmos. All right, so you're buying a car. If you want to buy a car wash at a gas station, it costs $5, and the cost per gallon is $3.10. All right, so you're buying a car wash and you're buying gas. If you have $40, write an equation to find the number of gallons you can afford. Now, it doesn't say solve it, but we're going to. All right, oh yeah, it does say solve. All right, and solve. All right, so again, what is staying the same here? What costs do we have that are not changing? Right, the car wash is not changing. It's still costing me $5. It's how many gallons of gas I'm putting in that's changing the cost on the gas. Again, cost per gallon tells you that this word is the cost, that's Y. Remember, it's Y over X when you do slope. Cost per gallon, so it's Y per X. All right, so cost is Y and gallons are X. And that's a good way to remember it. So anyway, I'm going to write my equation. Okay, the cost of this trip to the gas station, it's going to cost me $3.10 per gallon, okay, plus the $5 car wash. Okay, all right, so I'm going to put that into, oh yeah, and I have $40. So I have $40 to spend. So this changes to a 40. My total cost is $40 I'm allowed to spend, and they want to know basically how many gallons of gas can I buy, because remember, the car wash is still set at $5. So this, I would go over here, and I would just type that line in. 40 equals 3.10x plus 5. And look, see how you can't really see it? If I zoom out of here, now I can see it. And it looks like the answer is 11.29. So I guess I could technically pump that. It's not really realistic, but 11.29 gallons of gas. Okay, I might be able to do that. I mean, now that we have digital gas pumps, we might be able to do that. All right, so that's how that works for slope-intercept. Okay, I'm going to stop here, and then I'm going to do another video on standard form.